Okay, 10 seconds. Okay. All right, let's go over this. It's important that you understand how to balance an equation for today. There's a lot of stuff that goes into this unit, but one of the things that you're going to need to know how to do, or at least be able to recognize, is if an equation is balanced or not. So we are going to balance these equations together. All right, so the first one I'm just going to do for you, yeah? And then the second and third ones we'll work through together. So if you forgot how to balance a chemical equation, here's basically how it goes. We have Xe and F on this side. We call this the reactant side. And then we have an Xe and F on the product side. So we're going to make a list of what we see. I see one X or one Xe. I see two Fs. Okay. Over here, I see one Xe and I see four Fs. Okay. Don't forget that with balancing a chemical equation, we're never going to change the little numbers. We can't do that. Okay. We can't just add stuff in. I can't just like add a plus sign at the end and be like, all right, got it. Doesn't work like that. So what we're going to do is we're going to add numbers called coefficients out front that we will multiply by. Okay. So looking at our list, our Xe's are the same because we have one on this side and one on that side. And our F's, we have two on this side and four on that side. So we have to get this 2 to be equal to this 4. So what number can we multiply 2 by to get to 4? 2. So where do you put the 2? You put the 2 wherever the element is, out in front. Okay, so when we do that, this is 2 times that 2 right there, which is 4. So now we have one Xe on both sides and we have 4 F's on both sides. And so now we're done. If you do not put a number, what number is it? It's 1, yes. So if you want to, you can write the ones. I don't normally, but for today, why not? Okay. Sorry, I'm trying to get this thing up off my screen. Okay. All right, the next one works the same kind of way, right? So this one's actually much easier, in my opinion. So we're number 2. I see one Ca and one P on the reactant side. And over here, I see 3 Cas and 4 Ps, okay? This one is easy because on the reactant side, they're just 1. So if I have 3 Cas over here, what is our coefficient for Ca on the reactant side? 3, okay? Because when we put that 3 there, that's saying that we had 1, but now we actually have 3, okay? And then what would it be in front of P? 4, yes, exactly. So now we have 3 Cas on both sides and 4 Ps on both sides, which means you can put a 1 right there if you want. Okay. And the last one, I'm just going to go ahead and give you the coefficients for this one so you can check your answers. So we have 2 and 2. Okay, 1C, 1C, 2 O's. This 2 right here says we have 2 Fe's and 2 O's. So we got 2 O's, check. And then we have 2 Fe's here and 2 Fe's there. So we're good to go. All right, wonderful. So keep those off to the side because we will need those subscripts in just a little bit. Zoom, what I need you to do is on eClass, there is a document that says stoichiometry notes. It is, oops, not there. Luckily, what we're doing today is pretty easy. Okay. So this is the notes for the unit. So if you guys out here already have them, that's the yellow paper I gave you, but you still have access to this online, okay? So Zoom, you need to go ahead and open up this document because we're gonna get started like right now, okay? soon as I grab my paper. All right. Beautiful. So today we're going to be talking about mole ratios. You guys have been talking about ratios in math class for a really long time. I think pretty sure it's introduced for the first time in like 6th grade, probably before that though. So ratio should not be anything that's terribly new, right? If we have 5 cupcakes and 5 children, it's 1 cupcake for every 1 child. If we have 10 cupcakes and 5 children, it's 2 cupcakes for every 1 child. That's a ratio. That's what we're going to be doing today. Okay. So if you're using the digital copy of these notes, this black bar up here will actually be bright red. But we're going to fill this in. And for my Zoom folks or whoever's using it digitally, you do not have to erase this underline. You can just click right on the little blank and start typing, and it'll put your answer there. Okay. So we use mole ratios to find the ratio of chemicals in an equation or in a compound. Okay. So we got some pretty simple steps for mole ratio, which is really nice. And the first one is for step 1, we need to make sure that the equation is balanced. That is step number 1, is to make sure that the equation is balanced. Got to have a balanced equation. Okay. Then step 2, and the steps aren't going to make sense, at least step 2 won't until we start doing it. Write the ratio of chemicals using the, and it's not going to fit here when you're writing, so I'm sorry. You can just kind of like, write sideways. Coefficients. Okay, so we're going to be using the coefficients in a balanced chemical equation to do what we're doing today. So let's look at this example problem. Right? So it says use this equation. Step number 1, balance. Well, guys, we did this one for your warm-up. Ta-da! So our coefficients are 1, 2, and 1. So we balanced. Check. I'm not going to make you rewrite the balanced equation there. We don't need to do all that. Okay. However, what I will do is highlight these suckers for you, because I'm going to show you how we write our ratios. Okay. By the way, really the hardest part of this whole thing for mole ratios is making sure that the equation is balanced. That's the hardest part. The actual ratio portion is not, there's no math, by the way, for this part, for mole ratios. No math. So here's what we're going to have to do for our ratios. We basically have to make a list where we compare each part to each other, to all the other parts. So this is what it looks like. So you need to write or type as I'm writing, okay? For our ratios, what we do is we just look at the coefficient, and that is the number of moles that we have of that substance. So, for example, we have 1 mole of Xe to every 2 moles of F2. That's ratio number 1. We're going to have 3 of them, okay? So we have to compare this first one to the second one, and the first one to the third one, and then we got to compare these 2. So everyone's got to be compared to each other, okay? All I did here with the numbers, all I did was look at our balanced chemical equation and pull those numbers for that element or that compound. So the second one would still be 1 mole of Xe for every, and now we're not going to compare F2, we're going to compare the XeF4. So how many moles of XeF4 do we have? Based on the coefficient, 1 mole of XeF4. All we're doing is looking at the numbers from here, okay? And then the third one, we're going to compare these two right here. So how many moles of F2 do I have in this equation? 2 of them, because this number right here, this coefficient. So 2 moles of F2, and we're going to compare it to the last one. So same thing, 1 mole of XeF4. And that's it. That's mole ratios. Okay. We're going to practice here in a second. So go ahead and get your packet out, please. Huh? At the end of this unit, yes. Okay, we're going to be on page 9. Page 9 of your packet starts at question number 75. Okay. Page 5. All right. Everyone has a copy of their packet? Does anyone need a copy of the packet? No? Okay. Wonderful. So it's nice because the first couple of problems here that we're about to do, they list out the ratios for you. You just have to fill in the numbers. Do not overthink this. All you have to do, literally, all you have to do is look at the equation and pick out the number in front of that compound or that element and write it down. So if it says blank moles of HGO, you go and find HGO and then you write down the number that's in front of it, which is 2. Okay. ISIS, it's on eClass. Let me send you. You need packet. Page 9. All right, so this one is comparing HGO and HG. And ISIS, if you will go back to on eClass, and you're going to want to go to, let me tell you. Hold on. For those of you on Zoom who lost your packet or never opened the document, let me show you where it's at. I'm going to go to content. And then January 8th. No, wait, never mind. Ooh. January 11th. Sorry. Go to the lesson for January 11th. And it says stoichiometry packet right there. Okay. All right. Sorry. Continue. So 2 moles of HGO, and then it says for every how many moles of HG. So you come up here, you find HG, and then you literally just write down the number that's in front of it. That's it. That's it. Okay. So the next one, HGO, we have 2 because of that guy right there, compared to O2. So we come up here, we got to find O2. That's not O2, that's not O2, but that is, there's no number in front. So what number is it? Just 1. Good job. Okay. And then the last one, 2 moles of Hg for every 1 mole of O2. All you have to do is look at the coefficients. That's all you're using are these numbers right here. Okay. And the imaginary 1 that's there. What questions can I answer so far before we continue practicing? Any questions so far? Not surprised, you guys are rock stars. For those of you who've been staying with me, not so bad, right? So same thing here. We just look at our coefficients, just our numbers out front. So we find Na, and it's 2 because of that guy right there. Cl2, it's a 1. And then here, Na is 2, but then NaCl is also a 2. And then this is a 1, and that is a 2. So if you're wondering where I'm getting these 1s and 2s from, it's just from the equation, okay? We get it so far? I think so. You guys are pretty smart. Pretty smart. Let's look at number 81 super quick, okay? Because what's going to happen here in a minute is that, well, we're not going to do too much practice on just mole ratios today because we are actually going to add something to our math knowledge, which we're going to do moles to mole conversions. Those are going to be super fun. It's really not bad. So this one right here, 81, we're going to look at 81, all right? I don't want to waste time balancing the equation, so I'm going to tell you what it is. Let's see. Oh, it's already balanced. Oh, no, it's not. No, it's not. 2, 2. Okay, so here are our coefficients for out front. It's 2, 1, 2 for number 81. This is the only part that I think might be, quote, challenging about this. It's not hard, but you just have to remember, like, okay, so what do I write down in what order? Your order that you write stuff down in does not matter. It does not matter what order you write stuff down in. All that matters is that at least all of your parts are compared to each other. So what I like to do is I start with number 1. I like to start with number 1 and I compare it to 2 and then compare it to 3. Then I'll compare 2 and 3 so that I've compared all of them. Okay, so the first mole ratio, I'm going to start with number 1. I have 2 moles of NO. It is absolutely essential that you write the elements afterwards for what we're doing later. Okay, 2 moles of NO. So we're going to compare, this is 1, we're going to compare it to 2. So how many moles of O2? 1, good, 1 mole of O2. So that's the first ratio. There are 3 of them. Okay, so now we've compared 1 and 2. Now we got to compare 1 and 3. So 1 is 2 moles of NO, and we got to compare it to 3, which is 2 moles of NO2. And now I've compared 1 to both of these, but I have not compared 2 and 3 to each other. So we got to do that. So I'll start with 2, whatever. 1 mole of O2 for every 2 moles of NO2. And that would be how we write our mole ratios. It's not very challenging when they're listed out for you like this. It's this part that I think gets some people. But honestly, as long as you're comparing the 3, you'll get it all. Yeah? Okay, how do we feel about mole ratios? Yes? Okay. Do I have questions? If you have questions, you really need to ask. Okay? If you are uncomfortable raising your hand and asking me a question, just because that's your personality. Write it on a sticky note. Bring me the sticky note. Okay.
Miss, can you zoom up a little bit? Thank you.
Yep. Because what we're about to do is we're about to use what we know about mole ratios to do some math. We didn't really do any math here, but we're about to do some math. Lucky for you guys, the math is really easy. So that's nice. Okay. All right. Zoom. Head back to the notes page really quickly, and you guys like grab your yellow paper that I gave you at the beginning of class, please, and flip it over. So what we're going to be doing today is mole-to-mole conversions, which I got to be honest with you, are not challenging. They're not even a little bit, especially if they're only challenging if you have no idea what's going on in this class. If you have no idea what's going on in this class, you need to come talk to me at some point, please. No judgment. I just want to get you like caught back up, okay? So moles to moles, we use this conversion to go from moles of one substance to moles of another, a completely different substance. This part right here is so important. So important. I am telling you guys, for those of you who have listened to my advice about chemistry class this year, are the ones who are doing well, by the way, who've been staying on with it and all that stuff. This is a piece of advice that you need to listen to. What we're doing later this week, you are going to be in a world of hurt if you don't start using units and labels. Units like moles or grams, labels like the elements. I haven't really pushed the element thing too much, but when we do these conversions, now that we're in, this is the first day of unit 2, okay? So now that we're in unit 2, you are absolutely gonna have to write the elements after your unit. And I'm about to show you why, okay? So the steps are pretty easy. Step 1 is make sure that the equation is balanced, and if it's not, balance the equation. Then step 2, you're gonna set up the math with mole ratios using the template below. So I gave you a little template here, all right? And here's how this looks. Given moles of A, substance A. Guys, whatever the problem is giving you is substance A. Substance A is not a real thing, so it can be anything, all right? So in this case, given moles of A would be what the problem gives you, okay? Now, if moles of A go in the top, moles of A have to go in the bottom. And by A, I mean substance A. I'll show you in just a second. And then substance B, which is what we're trying to find, the moles for that will go up here. Let me show you how this works. It's actually very, very simple. Okay. So I'm going to leave the little template up here. So we've already balanced this equation once, actually really like twice now. All right. So here's the question. The question says, how many moles of F2 are needed to produce 6 moles of XeF4? So here's the difference between what we're doing today and what we have been doing. What we have been doing is using moles of one substance. How many moles are in this many particles of iron? How many moles are in this many particles of this? Okay, one thing. What we're going to be doing here is going from one element or compound to a completely different element or compound. Because we are going to be switching actual compounds or elements inside of our equation here, you have to label, have to. Because what we're doing, like, excuse me, 3 or 4 days from now, it will make your life so much easier, okay? So here's how we're going to do this. We already balanced the equation, so that's great. And we're going to set it up just like our little sample setup right there, okay? So it says here that we're going to do given moles of substance A. So whatever the problem gives us. They gave us 6 moles of XeF4. Guys, that means that XeF4 is now A. Okay. That's substance A. So it gave us 6 moles of XeF4. You have to write the XeF4 part. Have to. I have not pushed it for unit 1, but for unit 2, you have to. Have to. Okay. If moles of XeF4 is in the top, then you guys know, and you have told me that you know it also has to be down here. Moles of XeF4. Notice, I'm still using that XeF4 down here. Okay. And I put A here so that you know, oh, it belongs there. Yeah, okay. And now B is whatever we're trying to find. And it says, how many moles of F2? So our unit up here and our label is going to be moles of F2. This is the first time that we have done this where there have been different substances in the same equation. Okay. Now watch how easy this is. If you followed me so far, the hard part is over. All we do now is we use the mole ratio from our balanced chemical equation to fill this in. Just like we did in your packet just a couple minutes ago with like the blank moles of this. We're doing the exact same thing. So moles of F2, if you look up here, how many moles of F2 do you see in this equation? 2, exactly. So it'll be a 2 right there. And then moles of XeF4, how many? Just 1. Okay. And that's it. That's it. So 6 times 2, because we'll multiply these together, we have 12 moles you have to label because you have 2 different substances here, but the answer is only asking for one of them. It is not looking for moles of XeF4. In fact, they cancel out. The only unit we have left is moles of F2. You have to label, have to. But not so bad, hopefully. Okay. All right, grab your packet again, please, and turn to page 10 in your packet. Okay, page 10 in your packet. Okay, the first thing you need to know about this right now is that it says here at the top, solve the mole ratio problems below using this equation. This equation right here is what we are going to be using for the next 6 problems up until this line right here. So 84 through 89. This is the equation that we're going to use. One equation for all these problems. Nice. Okay. So the good part is it's already balanced. So you don't have to do that. So like really the hard part is over because it already gave it to you balanced. And by the way, I am so sorry if you've got a handwritten copy, there's an arrow in between there and it didn't print. So, all right, so let's set this up using our little template, right? So we have, and in fact, I'm going to color code because you know I love to do that. Okay. So how many moles of KCl, that's what we want to find, are produced from 4.9 moles of K? That's what we're given. This right here is substance A, is K. Substance B is going to be KCl. It's going to be KCl. So now we can use our my little setup I gave you. Or since some of you guys have been doing this with me every day, all day, you already know how to set this up. Okay, we'll start with what we're given. What are we given? Thank you. 4.9 moles of what? Of K. Good. You got to have that label. Got to have that label. All right. And I like to go ahead and put my units and my labels on the other side as well. So if moles of K is up here, it has to be down here as well. So moles of K. All right. And then what we want to find, which is B, see, B, we want to find moles, not of K, but of KCl. That's what we want to find. Okay. And now we do the mole ratio. All you have to do is look at your equation, just like we did. It's either going to be this number, or this number. Okay. So how many moles of KCl do we have in our equation? 2 of them. Good. And then moles of K? 2. What is 2 divided by 2? 1. Okay. So in this case, do we even need to multiply or divide anything? Think about this. Let's pretend that this 4.9 is actually 5. Okay. If we did 5 times 2, what's that? 10. And then if we divide by 2, that's 5. So we would end up with the same answer because this is 1, right? If you want to put it in the calculator, by all means, knock yourself out. But take my word for it. Moles of K cancels out. So we're going to have 4.9 moles of KCl. You have to label. Have to label. Okay. So it's set up just like the stuff we've been doing. Only this time, instead of using the 6.02 or the molar mass, we're using just whatever the equation gives us. Let's do one more together, and then I'm going to have you do a couple on your own, okay? So this one right here, how many moles of Cl2 are needed to produce 3.2 moles of KCl? So this would be our A. Sorry, this would be our B right here. And that would be our A, if you're following along. So have to label. 3.2, it's not just 3.2 moles, it's 3.2 moles of KCl. Got to have that, okay? Then moles of KCl will go down in the bottom. And then moles of whatever we're trying to find, which it tells us how many moles of Cl2 goes up here in the top. And now we use our mole ratio from the actual equation. So what number goes on top? 1, because Cl2, find Cl2, there's nothing in front of it, which means it's a 1. And then on the bottom for KCl, it's going to be 2. What kind of math are you going to do here with the 3.2 and the 2? You're going to multiply or divide? You're going to divide. Good job. Okay. So this ends up being, I'm going to just go ahead and tell you, 1.6. And then what's our unit? What's the unit? Moles. And then our label, Cl2. Okay. Because moles of KCl is going to cancel out. Okay, on a scale from like 1 to 3, how are we feeling? 1 being like, yeah, I wasn't listening. I don't know what's going on. Everything you're saying sounds like a foreign language. 2 is like, okay, I get it. Don't know if I can do it on my own. And 3 is like, nah, I mean, this is pretty easy. I probably could do this by myself. 1, 2, or 3. Y'all out here, show me. At home, tell me. 2, 2, 3, 3. Okay, 3, 2. Good, good, good. Okay, no shame, by the way, in 1s. That tells me that I just need to go over it again, and that's totally fine. I see lots of 2s, which I'm good with. I am good with 2s. I am so good with 2s, okay? Okay, so here's what I want you to try and do. So this one right here for 86, I'm gonna let you try it on your own in just a second, but here's the thing I wanna tell you. Sometimes in the problem, it doesn't actually give you the letters. And if you don't have your periodic table in front of you, that can be very confusing. So I'm gonna give you these, the potassium and the chlorine gas. Potassium is just K. And chlorine gas is Cl2, okay? Cool. So I'm gonna give you like a minute or so just to set it up, see what you can do, okay? And then we'll solve it together. Okay. What do we start with here in the first blank? What goes here? Yes, 3.5 moles of CO2. Or no, of Cl2, sorry. Can't hear today. All right, 7 moles of Cl2 is in the top, also has to go in the bottom. Okay, and then what's going to be our unit for the top, our unit and our label? Moles of K, good job. Okay, most of the work is done now. Now we just look at our equation, which is up there. Okay, so what number goes in front of K? 2, and in front of Cl2? 1. And then what are we going to do with these numbers right here, the 3.5 and the 2? We are going to multiply them. So 3.5 times 2, 7 moles of what? K. All right? Because moles of Cl2 are going to cancel out. Moles of K is what we have left. I told you guys, it's really not too bad. Really not too bad. Okay. All right. Here's what I want you to do. Okay. There are 10 minutes left of class. So here's what I want. I want one problem from page 9 of mole ratios, 1, and then one problem from page 10 that we just did. You can either do 87 through 89, or if you want to try one of the ones down here, you can. It's up to you. One problem, though. You don't have to do all of them, just one actual number, okay? So that's what you're working on right now. Zoom, you will send me your answers in the chat. And then once you do that, I will let you go. So when you do that, please tell me the number that you did and then the answer, okay? Same thing with you guys. When you're done, bring it up here and show me. Yeah? Okay. Does anyone need help?
Can you send this here?
Is it your constructive response?
Yeah.
Perfect. Thank you.
Wait, I don't know if my name's on it.
Anyone else have a constructed response to turn into me? Okay. If you have one to turn into me, okay, Isis. Do you have a constructed response to turn into me? You guys can send it to me on Remind. If you need to still do your constructed response, you need to come talk to me or send me a message, and I'll be happy to send you the instructions and the questions.
Miss, I kind of need to do mine.
Okay, yeah, yeah, you, I still have yours, John. So I can send it to you if you want to try it at home. And then, so Stephen, you need it. And I'll send it to John. Who else needs a copy of the constructed response? No one else? Okay. You need one? Okay. Yep. Good. Perfect. Superstar, of course. Perfect. Good job. Okay. Tony, there was a constructed response on Friday. Were you here on Friday? Okay. Yeah, that was that thing I put up, the 6 problems. Did you already send it to me, or were you actually in person on Friday, or were you online? Oh, yeah. Okay. Okay. And you handed it to me or sent me it on Remind? Okay, cool. Beautiful. Then I have it. Isis. So what you're going to want to do, in fact, Isis, okay, beautiful. Thanks, Denise. What you're going to want to do with these is that you're always going to want to start with like what you're given. Okay. So in this one right here, you're given the 5.5 moles of chlorine gas. Okay, that's what we're given because that's what the problem gave us. It's the numbers. What it wants to find is how many moles of potassium chloride. Okay. So what you're going to do, step by step, so the first thing you're going to do is we're going to set up this little like T chart looking thing like this. Okay. And when we do that, you can follow, this is in the notes for today. This is also in eClass, but this is the pattern of how we set it up. Okay. So what you're going to do is you're going to write your given moles of whatever substance A is. So whatever's given in the problem, whatever number. Okay. So we started with 5.5 moles of chlorine gas, which is Cl2. Okay. And then it says how many moles of potassium chloride. Potassium chloride is KCl. So then what you'll do is whatever this unit is right here, the moles of Cl2, if it's up here in this top box, yes, Stephen, good job, then that unit also has to go down here at the bottom, okay? So that means that moles of Cl2 will also go down here. Yes, Juan, good job. Josh, good job. Good job, Rihanna, good job, okay? And then our unit up here is gonna be moles of B, whatever this is, KCl. Which one? Yeah, you did. Yeah, you got it. Did you do one of these? Yes, you did all of them. Yep. Good. Let's see. Okay. So 1.9 moles, 2 moles, CO down there, and then good. Excellent. Good. Juan, Rihanna, Josh Brown, and Stephen, you may go. Goodbye. Beautiful. Looks good.
Bye.
Bye. Okay. So Isis, what we're gonna do? Good. Good. Perfect. Perfect. It's after school, baby. So you can do whatever you want. But like after you show me this? Yeah, that's fine. You can go head down. Yeah, I got you, girl. Sorry, Isis. Nicole, thank you. You are good to go. Isis, what you're gonna do here is the numbers that go here. You're gonna look at this equation right here, and one of the numbers that is like has a square around it, those are the numbers you're gonna use. So you're gonna look for this. Brandon, good job. You may go. You're gonna look for KCl up here, and it's right here. And then there's a 2 in front, so you're gonna put a 2. And then you're gonna find Cl2, which is right here, and there's no number written, so we're gonna put a 1 if there's no number, okay? And then how you actually do the math is you're actually just gonna multiply any numbers that are on top, separated by this thing right here, you're going to multiply those together. So the answer to this one is gonna be 11 moles, because we'll do 5.5 times 2. And then our unit is KCl. Okay.